Okay, so you have Abdul Hamid, Abdul Hamid, Afaf, Ilham, Khadija, and Rishita is also here. Fine. So the we have one lecture that we have to do for the chapter atomic structure. Okay. So what I will suggest is that in your notebooks who are with us from the starting, जी जी अब्दुल हमीद अभी फीवर उतनी नहीं है लेकिन थोड़ा वीकनेस आ जाता है ना फीवर आने से हल्की सी वीकनेस और कुछ खास नहीं है
Okay.
अल्हम्दुलिल्लाह and yeah, I've seen that in atomic structure we have one lecture left that was supposed to be on Thursday, but since I had to attend a funeral, so I, I was not there. Two is that this atomic structure I will take an extra class. Okay, somewhere after this week I will take the extra class, and so you have to leave a few pages. Those who have done the atomic structure chapter, they will leave a page. Leave not one page, either I should say leave 3 pages. Okay, just to be leave 3 pages, and then you will write the chapter's name, the third chapter, that is periodic properties or periodicity in elements and classification. No? Classification, periodicity in elements. So you can just write periodicity in properties of elements. Periodicity. Periodicity of properties. Elements. All of you guys, please leave 3 pages and then start writing periodicity of properties in elements. The chapter's name in NCERT is although classification and periodicity in elements, something like that. But the chapter's name, periodicity of properties in elements. All of you done? Yes, no, please tell me.
Yes, sir.
Yes, sir.
So now let us give the context of this particular chapter in the sequence of NCERT chapters. We first of all started with, you don't have to write anything now. We first of all started with basic concepts. In basic concepts, we will understand about mainly about the language of chemistry. And when I say language, you'll have to understand about letters, words, sentences, which makes up the elements, compounds, and the reactions. After that, how this reaction happens, that means that is the grammar of chemistry. That is stoichiometric calculation, all of these are grammar of chemistry. So I tell them this is grammar of chemistry. And then you will also have to learn about a few new terms. For example, molarity, molality, all of these are new terms for you guys, right? So in basic, we have to understand what are the language of chemistry that we are going to use. Then we went up to the next particular, we went up to the next very important thing, that is the structure of atom. Because everything happens inside an atom, we started to look at the structure of atom. And in this case, we had two different parts. We had quantum numbers and the history of atomic structure. And in history of atomic structure, we spent a lot of time in investigating the position of the electron inside an atom. If you, those who are present in the atomic structure from the starting, they know that when we write the, when we talk about atomic structure, we were able to understand the position of nucleus in first lecture itself. But in order to understand the position of electron, we first have to understand about the wave theory, right? Then the quantum, then the Planck's quantum theory, that each and every wave has some kind of energy associated with it. Then we have to understand the photoelectric effect, and then we went to the conclusion of Bohr's model of atom. And further on, we looked at a bit of quantum mechanical model, right? So the position and the status of electron was very important. And when we understood electron, then we moved on to the, I mean, first of all, we did quantum numbers, but you can associate from here now. When we understood the position of electron, then we talked about the address of electron, that is quantum numbers, right? Now, once you are done with this, Now, on the basis of these electrons, our modern periodic table has been arranged. But there were many attempts for a periodic table, and those periodic table they were made because some elements showed similar properties. Okay, they showed what similar properties, and that is why people attempted to make a table for them. So the first attempt. Now, what is the use of happen if some elements are showing similar properties? So when different elements are showing similar properties, then what you can do just, for example, I have element 1, 2, and 3, and we saw that when element 1, 2, and 3 they are showing similar properties, so we arrange them in a particular group or particular column like this, and then we started doing reactions. So when one was reacted with H2, sorry, when one was reacted with HCl, we got hydrogen gas. Now, if 1, 2, and 3 are showing similar type of properties, then we can predict that if I react element 2 with HCl, then it is also going to give you H2 gas. Okay. Element 3 is also going to give you H2 gas. So the number of experiments can be a bit less. Okay. That is why it was useful to arrange them in a particular order. So first of all, write the first topic, history of periodic table. Yeah, by the way, I don't know about Saudi, but UAE may or either you guys have cinema halls, right?
Yes, sir.
Yes, sir.
किसी ओपेनहाइमर देखा या बार्बी देखा?
दोनों नहीं देखा सर.
कुछ नहीं
Okay.
देखा.
No, sir.
बारबी कुवैत में रिलीज नहीं हो रहा, तो आई वांटेड टू वॉच दैट, बट
तो यूएई में भी नहीं रिलीज हो रहा है.
फिर यूएई में भी रिलीज नहीं हो रहा है. अच्छा, आई थिंक पाकिस्तान में भी रिलीज नहीं हो रहा है, मिडिल ईस्ट में रिलीज हो रहा है. अच्छा, अच्छा, नो वन आल्सो सॉ ओपेनहाइमर. Ilham, you want to say something?
नो सर.
तो बार्बी रिलीज नहीं कर रहे हैं. I mean, they will release after cutting some scene, right?
यस सर.
They will release after cutting some scene. So first of all, the first attempt was with Dauberniers. Okay, so Daubernier is like Dauberniers. Dauberniers law of triads. Law. This is law, okay, not laws. Law of triads. So what Daubernier did, he arranged three elements. Okay, 1, 2, 3 like this. 1, 2, 3 like this. Okay, he arranged things like this. And what he said was atomic weight of middle element. Atomic weight of middle element is arithmetic mean of other two elements. Other two elements. Atomic weight of middle element is arithmetic mean of other two elements when elements having similar properties are arranged. When elements having similar properties are arranged in increasing order, in increasing order of atomic weight. Let me know once you're done writing. Okay. So now what he actually did was, once he arranged elements with similar properties, what he observed was the middle element, it is having its atomic weight is the mean of the first and the last element. Okay. Now, then it occurred to him. So he started looking for these type of triplets, or he called them triads. So now he don't even need to check the property. What he started doing, he started taking the weights of different elements, and then started to mean it, and then check whether there is any element that is present of a similar weight. So his observation gave him this, at least these three categories. And as you can see, so here we have three triads, right? You have lithium, sodium, and potassium. And if you want to see 23 here, that is the middle element, right? The atomic weight of sodium is 23. If you add 39 plus 7 divided by 2, this will be equal to how much? 39 plus 7 will be equal to 46, and 46 by 2 will be equal to 23. Similarly, nitrogen, phosphorus, and arsenic, and boron, aluminium, and gallium. So all of these were having, the middle element was having atomic mass which was equal to the mean of the other two. Okay, so please write this down. After that, but this also had some limitations or drawbacks of this particular triad was that it was not applicable, or it was not true for all the existing known elements. Okay, so please write, it was not true for all existing elements. The point is that sometimes what happened, these categorization, if all the three elements, they had almost similar atomic masses. Okay, so obviously if you have similar atomic masses of all three elements, then the middle one is going to be obviously the mean of the first and last one. Okay, so this was another criticism. Please write next. Some of the triads had all the three elements having nearly same atomic mass. Done, everyone?
Just a minute.
Let me know once you're done. Done, guys.
Yes, sir.
Done, sir.
Now, second attempt was done by Newland, and what he observed was that when you are going to arrange the elements in the increasing order of atomic weight, then you will get the eighth element is going to have a similar property as that of the first element. And since the eighth element is going to have a similar property, then he called this particular law as law of octaves. So Newland's law of octaves. Okay. So he said that when elements, now these all things are observations. Okay. So all of these depends on the elements which are known at that time. Okay. And as you can see, all of these people, they are talking only about atomic weights. And all of you guys, what do you give more importance, atomic number or atomic weight? What do you think? What is more important? Abdul Hamid, Afaf, Amna, Ilham, all of you guys tell me.
Their waves.
What do you think? Atomic number or atomic weight? What do you remember first? When I say, for example, when I say aluminium, what comes into your mind? 13 or 27?
13.
13.
13,
Atomic
right?
number.
Atomic number, right? Now, this is because you have been asked and you have been told to memorize 1 to 20 in the class 10 standard. I know. And right
Yes.
now, what we have is that we already know protons and electrons. But in the times of Newland and in the times of Daubermeier, and further we are going to see Mendeleev's periodic table, all of these people, at that time, the protons and electrons were not discovered. And whatever chemistry they were doing on the basis of weights. So they did not even have the idea of atomic number. And that's why they are all talking about, and they're all talking in terms of atomic weight. Okay. So sometimes what happens when students, they learn about these things, they think that, oh, why is this so complex? You should just have done it so simple. If you look at atomic number, why get it complicated with atomic mass? Atomic mass is not very order wise, right? For example, sodium is 23, but if you go for calcium, calcium is just the double of the atomic number, 20 and 40. So many students, they think that why to go that route, which is very complex. So they did not choose that route. That was the only route that was available. Atomic weights, atomic number, did not even have an idea what is atomic number. The things were not discovered yet. Also, one more thing, not all elements were discovered at that time. So whatever elements they had to try, and they have to come up with some similar properties and some laws. So please, right? Newland said that when elements are arranged in order of increasing atomic weight, the properties of every eighth element were similar to the first one. Okay. Now see, if you look at the history of most of the scientists, so all of them, they were not as people think. The scientists जो सिर्फ किताब पढ़ के पागल हुआ रहेगा. All of them, they had some or other different hobbies. For example, uh, like you have not seen Oppenheimer, but Oppenheimer he knew Sanskrit also, and he was the one who translated Bhagavad Gita himself. Okay. Similarly, if you take the history of any scientist, you will see that they have some or the other interest or hobbies, and which they are very passionate about also. Maybe, and at that time, music was something which was for the elite class also. People used to go to orchestra and everything. So Newland saw these octaves as a very general rule, and he saw it a very poetic in nature. And he says that as in our musical notes, we have sa, re, ga, ma, pa, dha, ni. So this is 1, 2, 3, 4, 5, 6, 7. Sa, re, ga, ma, pa, dha, ni. And after that, again, किसी को नहीं आता. Again, what?
Sa.
Tell me. Sa. Right? So see, you can see the repetition here. Yes or no?
Yes, sir.
है ना. तो मतलब उसका दिमाग तो एकदम ऐसे हो गया होगा. नहीं, 2-3 दिन तक वो सिर्फ मुस्कुरा रहा होगा. Oh my God, मतलब गाना कहाँ कहाँ केमिस्ट्री दोनों को जोड़ दिया. नहीं. But obviously, so many people, when you join things now, music is kind of very natural in each and every society. Now obviously Newland did not have Saregama Padanisa. I think Western music has some different notes, but those things are very similar to the Indian notes. Anyone knows what Western notes are? I don't know
Do,
whether
re,
it is correct.
mi, fa, sa, la, di.
But those are similar only, no? Like the notes are
Yes,
similar,
sir.
right?
Yes, sir.
So the same. Now Saregama Padanisa is for Indian, so I remember this Indian one. That's why I said Saregama Padanisa. Now, as you can see, that is quite universal in that is not universal, at least in this world where music and people are there. Whether you start from Western music or you start from Indian classical music, you get the same thing. We said maybe this has something or the other related to chemistry also. So then he arranged things like that, and he arranged lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Then he adds sodium. Ab us time, see, as you know, what comes after fluorine? What comes after
Neon.
neon, right? Like right now, we know after fluorine, neon comes. Now, since neon is a noble gas will not show any reaction. That is why noble gas were discovered very late. Okay, so they were not discovered. And as you can see, so fluorine के बाद neon तो छूट गया, but उसको सारे कहाँ पता नहीं से मिल गया. And because neon was not discovered at that time. So you have sodium and then magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium, and so on. Also, one more thing is that it's not just that when you start with lithium, the sodium is going to match. Beryllium के बाद आप देखिए 7 elements. So 1, 2, 1, 2, 3, 4, 5, 6, 7. And then the 8th element is going to be magnesium, which will be having similar properties to beryllium. Okay. So this was Newland's law of octaves. Now let us write some drawbacks. So obviously you can see that the first drawback is that after fluorine. Now also one more thing. Who do you think who gave the drawbacks for Newland law of octaves? Who would give the drawback? Newland?
No.
Tell me, right? No. So the drawbacks come only after something new has been found out. Now, what I can say, it's not a very, I don't think it's a good idea that textbook also write Newland law of octaves and then they write just after that drawbacks. I used to also think that ये दोनों ने मतलब न्यूलैंड ने मतलब लिखा ऐसे 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 फिर ड्रॉबैक्स भी न्यूलैंड ने दे दिया कि मतलब मेरी थ्योरी के अंदर ये कमियां है. So obviously it's not like that. So what I think should be done is that once you read all the laws, so from starting whatever attempts were made and finally what we are learning right now, And then after we have learned whatever we know right now, we can compare the current theory with the previous theory and write the drawbacks. I think that approach should be a better one, in which is also going to be engaging. Like we have learned current theory is this one. Now compare this current theory to the previous theory and tell what are the drawbacks of the previous theory. So obviously we will just think that. Now also one more thing is that people don't learn the current theory until unless they have learned all the previous theory. So it's also kind of achieved कि मतलब अभी बताया ही नहीं current theory क्या और drawbacks बता रहे हैं कि ऐसा होना चाहिए ऐसा होना चाहिए. I don't know why books do, but you are right. Okay ना? तो साथ में लिख देते. Maybe it's because when revising it is easier to revise, है ना? But obviously दिखाने के time it seems very weird to me that I'm writing limitations just now without knowing the current theory. So limitations, what are the limitations? Limitation is first of all right here. Is right. This was only true for lighter elements with atomic mass which was less than 40. That means up to calcium it was valid. And the elements that were not discovered or that were discovered after Newland, they did not follow this law. Okay, so first is that only true for lighter elements. That is atomic weight up to 40. Okay, you can write 40U. Next point is elements that were discovered later. Elements that were discovered later did not follow the rule. Did not follow the rule or law. Let me know once you're done writing.
Yes, sir, done.
Next is Dmitry Mendeleev. Now, this guy, Dmitry Mendeleev, is someone that you can call a genius. Now, obviously, whatever contribution he made to the periodic table and chemistry, I mean, you can talk about them at very long length, but one should also remember his mother. Her name was Maria Mendeleev because his father name was Mendeleev also. I think it was Isaac Mendeleev or something. Now, Maria Mendeleev and Isaac Mendeleev, they had a glass factory. And they used to produce glass. And obviously, can someone guess where was Mendeleev from? Which country?
Russia.
Russia. Mendeleev, right? So by this, I mean, Eve, you can understand it is Russia. Mendeleev, Markonikov, some all the like ending with V, most of them are from Russia. Now, Maria Mendeleev and Isaac Mendeleev, they had a very large family. I think they had 8 or 11. I don't remember exactly. 8 or 11 kids. Now, most of them they were fine. I mean, no one was very talented, but Mendeleev, and also one more thing. At that time, when we talk about schools So school were not as we have schools, right? So obviously, when Dmitry Mendeleev was in school, he did not have periodic table to learn because he was the one who was inventing periodic table, है ना? So obviously, at that time, school was basic things that people should do, है ना? For example, how to cook things, everyone knew. How to fight people, everyone knew, because at that time you need those things. And then everyone should be able to run, because you don't know when a tiger is going to come. You don't know when a bear is going to come in your way, right? So all of these things were happening, but Mendeleev was not showing good progress in these physical activities. He was more interested in reading books, and he was more interested in doing arithmetics and mathematics and uh, learning about physics. Chemistry was not even a subject at that time, because chemistry was just in its infancy. And most of the people who were contributing to chemistry were either physicists, or they were you can say biologists. Okay, so biologists, when they dealt with chemistry, they were dealing with the living systems, and so you have biochemistry and the carbonates, compounds, that particular field, and the other fields are mostly because of physicists. Okay, and then came chemistry, and that is why chemistry is also known as central science, so where you apply the laws of physics on biological things. Okay, so leaving that. So Maria, she identified Mendeleev and his talent, and then she started going for and she started a journey in a wintry, chilly nights and days of Russia, and she almost traveled 2,000 kilometers to Moscow University. And she knew that if I keep Mendeleev in the same city and the same town where they were, it was not a city also, it was just a town, and they had college there, but she understood, if I am going to keep Mendeleev here, it will be a waste of talent. So she took up the travel of 2,000 kilometers with a sledge and a horse and traveled till Moscow University, only to get rejected there. She tried to show that Mendeleev is talented and everything, but Mendeleev did not have any recommendations from any other teachers and all. So after that, she again went further 700 kilometers to Petersburg. Now, St. Petersburg University, it was the same university in which his father was, Mendeleev's father, studied. And that is why he had some, I mean, there were some teachers who were also the teachers of his father. And that is why he got admission in St. Petersburg. And after that, once he got into, when he got into Petersburg Institute or Petersburg University, I don't remember what's the name. After that, he went on and got a master's degree in education. And once he was done with this, then he earned his PhD to the same St. Petersburg University. And after getting the PhD, he again started teaching at St. Petersburg, and he died while he was teaching there. Okay, so obviously this whole thing that Mendeleev, he became a phenomenal person in the field of chemistry. It was only because of her mother. Sorry, only because of his mother. If his mother did not take a long journey of 2,700 kilometers only with horses and sledge and by some walking, I don't know how many days and weeks it took for them to reach 2,000 kilometers and then further 700 kilometers, then we would not have the mental leave that we are having, है ना? और आपका सिलेबस थोड़ा सा कम हो जाता मे बी, राइट? बट सिलेबस क्या कम होता, शायद अभी हम लोग कुछ साल पीछे ही रह जाते. So the contribution of Mendeleev's mother is very important, and Mendeleev in his PhD thesis also, he, in the acknowledgement, he considered this as a gift for his mother. Now let us move on to the periodic table contribution. So Mendeleev's contribution is known as Mendeleev periodic table. Please write. Yeah. Mendeleev's periodic table. Now, this was, in the years 1865, 1870, something like that. He started teaching chemistry. And when he started teaching chemistry, he found that there were no good chemistry textbook. So, any guesses what he did?
Made a textbook.
He wrote a textbook. And so Mendeleev's problem had Mendeleev type of solution. So when he did not find any good textbook, he wrote a textbook. And the textbook was known as Principles of Chemistry. Now, while writing Principles of Chemistry, when he started teaching about different elements, and when he came into that particular chapter, and when he started to write about different elements, what he observed was that when you arrange element in increasing order of atomic mass, their chemical properties, they had a particular trend. Now, he saw this discovery and he called this periodic law. Now, if you remember, what is periodic? Periodic is that something which occurs after a certain period, right? So we say that it is periodic. For example, one periodic thing that you always have in your schools is periodic test. So a test which happens after a certain period. And he called this periodic law. So what was the periodic law? He said that when elements are arranged in order of increasing atomic mass, certain sets of properties recur periodically. Then everyone, yes or no, please tell me. All of you wrote this down?
Yes, sir.
Yes, sir.
Okay. Now, he also, like, the major importance of Mendeleev periodic table is that Mendeleev's periodic table had blank spaces. That means Mendeleev said that there are, now when I'm arranging them in their increasing order of, when I'm arranging them in their increasing order of atomic masses, I cannot find a few atomic masses. I mean, there should be some elements which are having this atomic mass, this atomic mass, this atomic mass, which will be discovered later on. So please write. Next, a point here is that Mendeleev's table had blank spaces where he predicted the unknown elements. What was these elements? These elements were later on discovered as germanium, gallium, and scandium.
That's it.
Now, done. Now, after that, He also, did some kind of. He also did some kind of. Wait a second. Let me show you this table. He also did some more experiments, and then he arranged after a few more years, and there were almost 8 elements for which he had blank spaces. Okay, so this was the first version of his periodic table. Okay. Now, as you can see, this particular after calcium, we have scandium, right? So he had left blank space for scandium and he called it Eka boron. So what is the meaning of Eka boron? That it is coming in the row of boron. And this he called as Eka silicon. That means it is coming in the row of silicon. It will have similar property as that of silicon. Okay, and this was Eka aluminium, which was later found out to be gallium. Okay, so these are the elements that in the first version of Mendeleev's periodic table, he said that, okay, fine, we do not have these things, but we will get these things later on. Okay, so these were 3 elements that he discovered.
So what's
Now,
the R2O, RO, R2O3?
So these are oxides. Okay, so when you do the formula of lithium oxide, if you remember from class 9, lithium has a valency of 1. Oxygen has a valency of 2, and if you do crisscross, you will get Li2O. Correct?
Yes, sir.
So these are different oxides. Okay, so on the basis of oxides, oxide was something that was of very great importance and in the initial times, because all of the elements, they had ores. So for example, if you want to go and find magnesium, so you will find magnesium oxide. You will not get pure magnesium in earth. You will always get it in a combined form, and that will be always oxide because oxygen is readily available in the air. And in the initial periods of earth, maybe magnesium reacted with oxygen, formed magnesium oxide, and then it is found in deposits as mineral and ores. So these oxides were the initial source of chemistry. And if you know, I don't know whether you know Dalton's history. Dalton was also a meteorologist. So he used to study different meteors and minerals. Okay, so that was also minerals and meteors. All of these things were the initial phases of chemistry where the chemistry started, at least for the people who were from the physics background. Okay, so you don't have to write this thing. Now, right next. After Mendeleev, we are obviously going to write what some of its drawbacks. First drawback is, since they are arranging them in the increasing order of atomic weights, they should do something about the isotopes. But none of them did anything about the isotopes. Okay, so isotopes were not considered. Isotopes were not considered. Then the next thing is position of hydrogen lanthanides and actinides were not correct. Last is some similar elements were placed in different groups.
So what's after hydrogen? You wrote.
Lanthanides, Lanthanides, and
Yes, sir.
actinides placed in different groups and vice versa. If you, what is lanthanide and actinide? So these are the F block elements. So if you see the periodic table, modern periodic table, there is a block like this at the end, right? So this particular first period, it is known as lanthanides, and this row is known as actinides. Okay, so they were not given a particular place in Mendeleev's periodic table. All of you done? Yes or no? Please tell me.
Yes, sir.
So,
Right, next, the modern periodic law. Now, please write. Physical and chemical properties of elements are periodic function of their atomic numbers. The periodic function of their atomic numbers. So what does it mean? Is it meaning when elements are arranged in increasing order of in increasing increasing order of their atomic number, the elements with similar properties, the elements with similar properties are repeated after are repeated after certain intervals. All of it done?
Yes, sir.
Okay. Now, right, next, the cause of periodicity. So in the atomic structure, we learned the importance of the position of electron. And the most important thing in the position of electron is the position of the outermost electron, the valence shell electrons. And what later on scientists, they saw that when we are arranging them in increasing order of atomic number, then there is a repetition of similar properties also, and the properties were similar only of those elements that had similar electronic configuration, similar outer electronic configuration. So the cause of periodicity is what? The repetition of similar outer electronic configuration. Okay, please write. It is due to, we will also see this once we start looking and studying the periodic table. It is due to the repetition of similar outer electronic configuration. After certain regular intervals.
Done, sir.
The modern periodic table. Now, all of these informations are very important. They can be asked directly in your exams. It consists of seven horizontal rows, called periods. It consists of 18 vertical columns, called groups. It is further divided into four blocks. What is this block? First is S block, which is group 1 and group 2. P block is group 13 to 18. B block is group 3 to 12. And F block is group.
Done, sir.
Okay. Now, can all of you go to the Learnivio app? And then go to class assessment. There you will see